Which one are you doing?
Which one?
Number 1.
Number 1.
Wait, will it be able to hear our audio?
Yeah? Yeah, it'll hear you bouncing the ball and probably bouncing it off your head. And me talking about it right now.
Any of them on the
Can you
second
do number
page?
2, please?
What does 2 say?
2 is f of x. I know, but I've changed my mind. 2 is f of x equals x squared minus x minus 6 over x squared minus 2x.
You live?
Minus x minus 6?
Yeah, and then x squared minus 2x. This one looks harder, so I'm doing this one.
Okay, so the part about the symmetry is going to be one of the last things you do because whenever you graph it. Okay? So x-intercept, so whenever it's the x-intercept, so if we're going to go here, you're going to take that's when it's 0. So basically all you're going to do for B is set the top equal to 0. So minus x minus 6. So when it's equal to 0. So how are you going to solve a quadratic when it's equal to 0? What's the easiest way? In this case, factor it, right? So I'm going to have x minus 3 and x plus 2 equal to 0. So when does it cross the x-intercept? 3 and negative 2. So then your x-intercept is at x equal to 3, x equal to negative 2. Y-intercept, set the so for the y-intercept you just set everything equal to 0. So if I go 0 squared minus 0 minus 6 divided by 0 squared minus 2 times 0, what's the problem here? You're going to have 0 in the denominator spot. So is there a y-intercept in this case? None, or if you just did, like in that case it's not applicable. Vertical asymptotes, that's going to be x squared minus 2x equal to 0. So what are your two asymptotes? Zero and positive 2. So then that's where, like, and I can't scroll, like once you figure out your asymptotes, I would go ahead and draw your asymptote on your graph. E and F, it's going to be one or the other. So E and F, you're basically looking at, so blue. If they're the same, then it's whatever the lead coefficients are divided by each other. So they're the same power, right? So that means I'm going to take basically x squared divided by x squared, which is just going to be what? So then I'm going to go to 1, and you're going to kind of be able to see this. You're going to have horizontal asymptote at 1. So then if you have a horizontal asymptote, that means you don't have a slant. Then if it's a slant, so slant's going to be like on number 3, where slants whenever it's like if it's x to the third over x to the second or whatever. Yeah, whenever the top's bigger than the bottom, that's when you have a slant. If the bottom's smaller than the top, so like if you have an x squared and then an x to the third, then your horizontal asymptote is y equal to 0. When they're the same, that's whenever you take the coefficients and divide them. So since there's not a asymptote for the slant, it's just going to be none. Your domain's going to go from basically your horizontal asymptote to your your negative infinity through your asymptotes. So from there to 0, 0 is not included. From 0 to 2, and then from 2 to positive infinity. No, because those are your asymptotes. So that's like, it's like your restrictions are wherever your domain is. Now your range, I would say, like if you have a graphing calculator, use a graphing calculator. Okay, especially for the graph, because then like what this one looks like is going to be basically like this, and then you're going to have your here, and then like that. Okay. I can't scroll up because then I'll lose everything that I have there. The range is all your y values. So like in this case, your range values go from negative infinity to the 1. And then if I remember right, it picks up like this. I think it's at 1/6. Okay. It's going to split your asymptote, like whenever it's a cube and it has like the part running down and then it has the quadratic in the middle, it's going to split your asymptote in half and be a quadratic basically. So since it picks up at 6, it's going to go from, it's going to include 6 to positive infinity. And I just got the 6 by plugging the 1 in, because it's going to, like, between 0 and 2 is 1. Does that make sense? So since it's not on, since basically the whole thing's kind of shifted over to the right, it's not the origin. Okay, this one's going to have no symmetry whatsoever. But like on number 4, I think on your problems, it does have like y-axis of symmetry. It basically falls right in the middle, and everything matches. Like I could fold it right on the y-axis.
Is this how it'll look on the test?
Yeah, this is actually one of the problems from the test.